Hi, I'm Adolph Oliver, and this is the video clip about solving mixture problems using systems of equations. Now, you're going to run into this a lot in chemistry where they love to mix various chemicals together to get certain concentrations, but that's not the only place. These things show up in business where it's often necessary to combine two different blends of, let's say, coffee or nuts, for example, to get a desired final concentration. Now, mixture problems are similar in many ways to value problems, but there's usually one extra calculation that must be made. Let's look at some examples. Here's a typical mixture type of problem. It says here Jenny wants to make 12 quarts of a 38% saline solution. Saline, of course, meaning salt. And what she's going to do is mix together a 60% saline solution and an 18% saline solution. Now notice that the amounts that we're talking about here are in quarts. So here's the first thing you want to do. The two guys that are being mixed together, set up variables for them. So for instance, X could equal the quarts of the, let's see, what's the first one they mentioned here? The 66% saline solution. Okay, remember the 38% here is what we want for the final mixture. And Y is going to equal the quarts of the 18% solution. So now you've clearly got these labeled, defined, so you know what you're using, and anybody looking at your work can tell what you did as well. Okay, there are two equations. The first one is always a simple one. I call this the total equation. And what it is the total amounts that you're going to mix together to get the final amount. So we have X quarts of the 66%, so X plus Y quarts of the 18% solution equals the total amount that we want, which is the 12 quarts from back up here. Okay, now that's your total equation. The next thing you do is you put the value, which in this case is how much salt is in each one of these. So I like to call this the value equation here in the mixture business we're doing. Now notice that we're talking about percents here. The final mixture, 38, the two things you're mixing together, 16 and 18. You could convert these to decimals, okay, and then turn around and multiply everybody by 100 and convert them back to whole numbers. So let's just say that we did all that and take a shortcut and simply do this. The amount of salt that's going to be in the X solution here is 66 times X. In other words, I've written the percent here just as a whole number, 66, because I'm going to do that with all of them, and as long as I treat them all that way, we're good. Okay, now, plus Y, which is the 18, so I'll go 18Y, okay, equals, now here's the thing that you have to make sure you do. Remember, we took X and multiplied it by how much salt it had, Y multiplied it by how much salt it had. We got to multiply the 12 here by how much salt it also has, and it's going to be 38%, which again I'm just writing as a whole number here, times 12. Okay, well these are the two equations that'll solve it for us, and this total equation makes it real nice to work with. Usually elimination is a good way to go. So let's see, the smallest coefficient here is with the Y, it's 18. So what I'm going to do is take this total equation here and multiply it times negative 18. And what that will do then is clobber out the Y's, then we can solve for X and go back and get Y again after that. So take the total equation, multiply everybody by negative 18. So negative 18 times X, negative 18 times Y, and negative 18 times the 12 on the end. Okay, just write it like this for the moment. Don't multiply it out because I'm going to show you a shortcut. Okay, well now we combine these two and we designed this to get rid of the y's. So let's see, what do we have here? 56, looks like 48x, okay, equals, now here's an interesting another trick you can use. Remember, we're combining like terms. The x's are the same, so I can combine the coefficients. The y's were the same, I can combine their coefficients, they zeroed out. Well, look at the 12s here. They're the same. So you can actually do the same thing with numbers as long as they're the same. We can combine the coefficients. 38 minus 18 looks like it's going to be what, 20, I guess, huh? Okay, and so, and of course, don't forget that we have the 12 here that's constant. It's just like we had the x's. So a nice little shortcut here for solving these guys by doing this. Okay, now, well, let's solve for x. We got to divide both sides by 48. Notice I haven't gone over here and multiplied this out yet because you can often reduce this down without multiplying. The 48's cancel here, of course, so we get x equals. Now, 12 and 48 reduce into each other. 12 goes once, into 48 it goes 4 times, huh? And notice 4 reduces into 20. Remember, you can just keep reducing. And so, well, we don't end up with a denominator. That's 1. The numerator is 5 times 1, so we get x equal to 5 quarts. Okay, so going back up to our top up here, we know that x now equals 5 quarts. Now, generally real easy to get y here because you got this total equation. You can do this in your head. If x is 5, what does y have to be so they add up to 12? I think y has to be 7, doesn't it? So if x is 5 and y is 7, 5 and 7 are 12. So just figuring that out, you can write it out if you want, but it's often simple enough to do that. So there we are, 5 quarts of the 66%, 7 quarts of the 18%, and what that will end up giving us is what we wanted here, the 12 quarts of a 38% solution. Okay, here's another example for us to look at. Brand X here, Peanuts, sells 18-pound bags of mixed nuts that contain 26% peanuts. Well, this is what we want to end up with. 18 pounds and have 26% peanuts. To make their product, they combine Brand A mixed nuts, which contain 16% peanuts, and Brand B mixed nuts, which contain 52% peanuts. Okay, well, remember it's pounds that we're going after here. So, well, let's use the letters A and B that they mention here. So A is going to equal the pounds of the, what was A here? 16% peanuts. Pounds of the 16%. Okay. And Brand B, okay, is going to contain, and it's in pounds just like the other, of 52% peanuts. Okay. Now, one thing to point out to you here, whenever you're making mixtures here, and these are the two things we're mixing together, the result has to be a value which is in between these two. And the result up here is going to be 16%, so it's workable. We can do this. Okay, well, let's get the total equation. Total, okay, A plus B. Now remember, A is the pounds of the 16, B is the pounds of the 52, and we want to have a total of 18 pounds when we finish up. So there it is. That's our total. Once you get the hang of these guys, they're simple to do, because now what you do is just take the total equation and multiply it by the concentrations. And if they're all in percents, you can just deal with them as whole numbers. So I'm going to take 16 times A. That represents the 16%, but I've written it as a whole number here. Plus B is 52. That's the concentration of that. Now remember, you got to do the same thing out here. We want to end up with 18 pounds that are 26% peanuts. So I'm going to go 26 times the 18. Okay, there we go. Now, again, elimination works beautifully on this because of this total equation being so simple. The lowest coefficient is the A here with the 16. So what I'm going to do is take this first equation, multiply it by negative 16 to eliminate the A's. So negative 16A minus 16B equals minus 16 times the 18. So again, just take your total equation, multiply it by the concentrations, we've converted them all to whole numbers, and then eliminate one of the variables. A had the smallest coefficient, so we decided to eliminate that. So here we go. Let's continue on. The A's go out, so let's see, we're going to end up with B's. 42 looks like we'll end up with 36 B's here, positive. Okay, now remember, once again, this trick. The 18s are the same. I've got 26 of them here, minus 16. That gives me just 10 left, so 10 times 18. If you have a simple problem, then you can often just reduce the answer out and save yourself the trouble of multiplying these things. And I think that's going to work for us right here once again. Let's divide both sides by 36 to get the value of B. So B is going to equal, well, let's see, 18 goes once here, and the 36 it goes twice. Yeah, this is easy. 2 goes once here, and the 10 it goes 5. So B equals 5. Okay, well, going back up to where we labeled this thing then, B equals 5 pounds, okay, that we're going to want to have. And again, remember, you can usually figure out the other guy right in your head. If B is 5, okay, which we just got, what does A have to be? So when you have A plus 5, you get 18. I think A has to be, what is it, 13? So it equals 13 pounds. Okay, there we go. I mean, you can write this out. If A is 13 here, 13 plus 5 is 18, so there we go. Well, once you get the hang of how to set these guys up, these mixture problems are not difficult to do. Okay, here's another example, and what we're talking about here is mixing together some juices. And here's what we want to end up with. So it says, Carlos asked you to make 15 liters. Now, okay, so there's the total amount we want in liters of fruit punch that contains 61 fruit juice. Okay, so this is what we want to end up with, and 61% fruit juice. Now, what are we mixing together here? Some sweet tropical fruit punch. Well, fruit punch includes juice and other things, and some grape juice. Okay, well, let's see. Let's say we make F equal the fruit punch, and it's in liters. So liters of, and now let's read on here. How much of each ingredient do you need if the sweet tropical fruit punch contains 35% juice? Okay. Remember we said the fruit punch here had juice plus other things? Well, it's 35% juice, and of course juice is what we're keeping track of here. So F equals liters of 35%. Now, the other thing we're mixing in here is grape juice. Let's use G for grapes, and it's going to be liters again of Now here's the thing, notice, grape juice. This is pure juice. So, what's the amount of juice in it? Since it's all juice, it's 100% juice. So here we go again. The tropical fruit punch contained 35% juice. The grape juice we're mixing in, notice, is just plain juice, so it's 100% juice. So here are the two guys that we're starting out with. Okay. Now, first off, our total equation. Okay, just add these two together. F plus G. This is the liters of the tropical fruit punch and the liters of the grape juice. Well, that's got to equal the total liters we want, which up here was told us was 15. Okay, now what's the value or amount of grape juice or juice I should say, in each one of these? Well, remember, the fruit punch had 35% juice, so 35 times F. And the thing here you got to realize, okay, since the grape was just plain juice, it's 100%, so 100 times G equals, now don't forget, we also have to multiply the guy in the end by the percent of fruit juice that's wanted in there, and this is 61%, so 61 times 15. Okay, once you get these two equations set, now you're all set to start solving this. The guy with the smallest coefficient is the tropical fruit punch here with the F. So I'm going to take this guy here and multiply him by negative 35. And you got to multiply everybody. Remember, this is a balance scale thing. So negative 35 times F, negative 35 times G equals negative 35 times 15. Now again, what I did here was just take the total equation, multiply everybody by negative 35. Why did I pick negative 35? Well, I decided I wanted to eliminate the F's. Okay, and now let's see what we end up with. Okay, here we go. So let's go a little further with this. Okay, the F's go out. 100 minus 35, let's see, I think that's what, 65? 65G equals, now let's see what we end up with here. 61 minus 35, I think that's going to be 26, huh? And remember, of course, the common, just like the common variable G, the common number 15 comes down here. Now let's make 11, 561, yeah, it looks good. Okay. Now, if this is a fairly simple problem, we might be able to just get the answer by reducing. That's why I always wait and don't multiply this out, because you can save yourself some work often. G equals, well, let's see, I can see that a 5 will reduce into both the 15 and the 65. 5 goes into 15 3 times. 5 goes into 16, I think 13 times, huh? 5, 6, 13, go, look at this. 13 and 26 reduce. Okay, so we reduce the denominator all the way. This is another one of these problems that has a nice answer. 2 times 3, 6 is the value for G that we want. So if we go back up here then, okay, this is going to be 6 liters of the grape juice. Now again, you can usually do this in your head. If G is 6, what's F have to be? I think F has to be 9, isn't it? 9 plus 6 is 15. So here we go, 9 liters. Okay, well, I hope you're seeing here that once you get the technique, get the total equation, then multiply it by how much you have, and after that it's a simple elimination problem to be able to come up with your answers. Okay, here's the last example to look at as an example of these mixture problems. It says a metallurgist, who is a person who works with metals, needs to make 6 ounces, here we go, of an alloy containing 25% iron. Alloy just means it's a mixture of things. He's going to melt and combine one metal that is 50% iron with another metal that is 20% iron. How much of each? Well, okay, let's just go use our old x's and y's here. Let's say x equals, now notice again it's in ounces, so that's why I know what units to put here. X equals the ounces of, let's say, the 50% iron mixture he's going to be using. And we'll go put y here equals, again, the ounces of, and what's the other one here? 20% iron. Okay, so once again, we've got these labels so we know what we're doing, and anybody looking can tell what we're doing. Now remember, of course, the final mixture has to be a value between 20 and 50, and 25% is definitely between these, so it's something that's going to work for us. Okay, once again, the total equation. Well, we just add the x and y together, x plus y, and how many total ounces do we want? What did it say? 6. Okay, so there it is. Always easy to get this first total guy. Now, what's the value? In other words, how much iron is in each of these? Well, remember again, since everything's in percents here, we can just treat these all as whole numbers. So let's see, the x is 50%, so 50 times x, plus the y is 20%, 20 times y equals, now here again, make sure you put down what the concentration is that you want of the final mixture. So it's going to be 25% times the 6, and of course we wrote these all, since they would all be in percents. We could of course make decimals out of them and then multiply back and make whole numbers out of them. So here we are, just take the whole numbers to begin with. As long as everybody is a percent, you can do that. Well, okay, looks like the y has the lowest coefficient here. So I'm going to take the total equation here and multiply by negative 20 to clobber the y's. So I get negative 20x minus 20y. Remember, we're multiplying the first equation all the way through. Don't forget you got to multiply the guy on the right too. So minus 20 times 6. Okay, let's start working on this to see what it is that we've got here. Okay, the y's go out. That's what we designed here. So it looks like 50 minus 20. Looks like we got 30x equals. Now remember again, since these 6's are the same, we can treat them just like a variable. Think of these as coefficients and combine them. 25 minus 20 is 5, and then of course don't forget the 6 is just like your variable x here. Well, I think we can see what the answer on this one's going to be real quick here. Okay, x is going to equal, the top is 30, isn't it? Well, if we reduce it out, 6 goes into 35 times, and then 5 goes into 5 once. So we got 1 over 1, so x equals 1. Okay, well, that means we know that what we want here is 1 ounce of the 50% stuff. And then how many ounces of the 20%? Well, remember again, you can do this in your head. If x equals 1, 1 plus what equals 6? I think y has to be 5, isn't it? So 5 ounces of the y. Okay, well, there's how mixture problems are worked out.